next experiment, we are now see here we are going to store some 10 bit some 10 numbers in an array. Okay, so we are going to store some 10 numbers in any memory location, and from that 10 numbers we are going to find which one is the largest number. Okay, so for that, first of all, we have to store the 10 numbers, and then we are going to do the programming to find out which one is the largest number. Okay, so for this we need different instructions. Already we have gone through different instructions in our theory class also. Okay, but the main instruction which we are going to use is the move instruction, maybe the indirect addressing mode or maybe addressing mode, and the next one is the increment one instruction. Okay, so the second one is the compare CJNE, that is compare and jump if not equal to. Okay, then SJMP, that is simple jump. Then third one is DJNZ. Okay, so these are the different instructions which we are going to use, and with the help of these instructions we are going to perform the experiment. Okay, so I'll just open the Kill software. So I'll close the project. Okay, so I'll open the new project, new microvision project. So I'll write the name as biggest, your batch is S1. Okay, so biggest number for S1 batch. Okay, save. Then it will ask for the device. Okay, so it is 89C51. Okay, I'll select this 89C51. Okay, then you have to select this no. So your target has been added to the project group. Okay, next I will open the new file. Okay, so here is the text file where we are going to do our programming. Okay, so first of all, I'll save this file as biggest S1 batch. Okay, then as we are doing the programming in the assembly language, in assembly language, so I'll make it as .asm. Then save. So here you can see the name has been changed to biggest S1 batch .asm. Okay, so now I'll add this program file in the target file with the help of this source group. Okay, so add existing file to the group. So this is .asm file. So biggest S1 batch .asm I have added. So close. So you can check your file if it has appeared here or not. Okay, so it has appeared. Now I'll start the programming. Okay, so before that we'll just do the settings. So we have to add first of all the target group. Okay, so again options for the target 1. I'll set the frequency, it is 11.0592. Okay, then output we need the create hex file. Okay, so I'm not using the simulator, so I'll choose the hardware. Okay, so I'll just go for the option as okay. Okay, so save. So your file has been saved with the all the options, and even it has been added to the source group. Okay, so we'll go for the programming, how to find out the largest number from the array of 10 numbers. Okay, so for that, first of all, we have to initialize the memory location. Okay, so I'll just go for org 00h. Okay, then I will take one register which will be acting as a counter. Okay, so I'll take the register as R1, and to this I'm going to give the value, that is immediate addressing. I'm going to give it as a counter, so it will just take down the value as a counter. Okay, so 10 values we are going to take, so I have assigned the counter with 9 values. Okay, so it is going to take it from 0. Then I'm going to again take another register. Okay, so which will, with the help of the immediate addressing, I'm going to give it the value as 40. Okay, now this 40h is going to be the memory location from where I'm going to give the this is the first memory location from where I'm going to store my 10 numbers. Okay, then from that memory location, I'm going to move from the memory location R0. I'm going to move the data in another number or another memory location. So I'll just take it 55H. Okay, so you can pick any number. So I have taken it as a 55H. Okay, so from the location R0. Okay, so this indicates that it will indicate the contents where the R0 will indicate the contents where the it will indicate the memory location where the contents has been stored. Okay, so from there it will transfer the value to the next location, that is 55H. Okay, then after that I'll just increment R0. R0 is nothing but it is your memory location where you have stored your data. Okay, so I'm going to increment the R0. Next, from, so I have taken already one number from the memory location 40H, which is stored in 55H. Okay, so I have to compare with the second number. So for that I have to again take the second number from the next memory location. Okay, and that number I am going to take it in the accumulator. Okay, so a comma at the rate R0. Okay, so what has happened, uh, in the earlier case your R0 location was 40. Okay, so from that memory location your contents has been transferred to the next memory location, that is 55H. Okay, so after that I have incremented the register R0, that means after 40 it will become as 41. Okay, so the next content in the memory location 41 will be transferred to the accumulator value. Okay, then after that I'll use the command as CJNE. Okay, that is compare and jump if not equal to. Okay, so it will compare the values in the contents in the accumulator as well as the contents in the memory location 68. Okay, if both are not equal, then it will go to the label. Okay, so it will go to the label down. Okay, then if it is both are equal, then it will simply jump to the next label. Okay, so next label I have made it as a simply jump to label L1. Okay, so where I'm going to take that label L1, I'll just tell you after this. So it will compare these two values, the value in the accumulator and the value in the 60H. If both are not equal, then it will jump to the label. Okay, now this down label I have taken it here. Okay, so what it will do, it will just compare, it will check whether the carry flag has been generated or not. Okay, now suppose if I am going to compare the two numbers. Okay, so the number which is there in the accumulator, if it is greater than the second number, the carry flag will not be generated. If the number in the accumulator is less than the other number, then the carry flag will be generated. Okay, so that's why I'm going to compare the carry flag whether it is generated or not. If the carry flag is generated, so what this instruction said, that jump with carry. That means if your carry flag is equal to 1, it will jump to the label. Okay, so label L1. Okay, I'll consider this label L1. Okay, then I'll move the contents of the accumulator in the next memory location, that is move. This is new. This is, sorry, this is 55H memory location where the accumulator values, that means the number which is stored. So this should be 55. So I have taken the memory location because it is going to compare the contents in the memory location 55H and the accumulator. Okay, so uh, so whatever the accumulator value is there, okay, if the number is greater in the accumulator, it will be transferred to the next memory. That means the result will be stored in the location 55H. Okay, so if the carry is generated, if the carry, that means if your carry flag is set to 1, then it will jump to the label L1. Okay, so we have not still defined the label L1. Okay, so if L1 is, the label L1 is defined as DJ and Z. Okay, that is decrement and jump if not 0. So what it will do, it will compare the counter, that is register R1, with the value 0. If it is not equal to 0, then it will go to label. Okay, so what is that label? So the counter has to be decremented, and the register R0, that means it has to go to the next memory location. Okay, so we have to point out the next memory location, and where it is going to be point out to the next memory location, that is increment your R0. Okay, so this is your next label where it has to come. Okay, so this is how your programming is done, or there is a comparison between the two numbers in the accumulator and the next number which is stored in the memory location 55H. Okay, so this is the programming. For that, first of all, we have to assign the memories, and we have to give the 10 numbers in the memory location. Okay, so I'll just first of all we'll see if there are any errors. Okay, I'll save this program, translate. Okay, there are no errors, no warnings, so I'll just build this program. Okay, now before going for the start and debug, okay, so there are no errors and no warnings, so I'll start and debug. Okay, so it will give the evaluation mode. You have to just say it okay. Now first of all we have to give the 10 numbers to the memory location. Okay, so in this file you can check, this one is the option where you will get the memory window. Okay, so there are 4 windows are there, in that you can choose any one. So memory 1 I have chosen. Okay, so the window of the memory 1 will be shown here. Okay, so just to observe or to show you properly, I'll just take this memory location here. Okay, so it will be easy for you to observe how the data transfer will take from one memory location to another memory location. Okay, so one memory location to another memory location. Okay, so what memory location I have given? I have given the memory location as 40H. Okay, so to get that memory location, I am going to type D colon 40H. Okay, we will get all the memory locations from D40H. Okay, so to show the transfer of the data from 40H to 55H. Okay, now instead of this, I'll just take this next memory location. Okay, so that it will be easy for you to observe how the data transfer is going to be taking place. Okay, so I'll take the next memory location, that is 66. Okay, so it will be easy for you to check how the data has been transferred from one memory location to another. Okay, so this is the memory location. So this is the memory location. So first of all, we have to give the 10 numbers. Okay, so I'll just give the first number as 01. Okay, so I'll give it sequentially, so it will be easy for you to observe. Second number is 02, then 03, 04, 05, 06, 07, 08, 09, 0. So these are the numbers, hex 8-bit numbers what I have given. So these 10 numbers I have stored in a memory location 40H. Okay, so we have to execute this program and now check how the data transfer and the comparison of the two numbers will be done. Okay, so first of all we'll see, now see here what is the first instruction, that is move R1 with the value as 0. Okay, so you can check the value of the register R1. Okay, it should get the value as 09 now. Okay, I'll just execute this program line wise. See here, R1 has got the value as 09. Now the register R0 should get the value as 40. Okay, so this is going to act as a register counter, and this R0 is going to be the memory location from where we are going to get the contents, because we have stored our 10 numbers in the memory location 48. Okay, so what it is saying, that from the first memory location get the number in the location 66H. Okay, so if I execute this instruction, you can check that you will get the first number. What is your first number in the first location, first memory location? That is 01. Okay, so this 01 number has to be transferred to the memory location 66H. Okay, so if I execute this instruction, I'll get this number in the memory location. So what I have done, uh, so I have given all the 10 numbers. I have stored all the 10 numbers in the location 40H. Okay, so this is location 40H where I have stored all the numbers. Okay, so you can check in the first, if I execute the first instruction, R1 has got the value as 09. Okay, R0 has got the value as 40H. Okay, next instruction was that the contents of the memory location pointed by the R0 has to be taken into the memory location 66H. Okay, so what was the first contents in the memory location? That value was 01. Okay, so this 01 has to be transferred to the next memory location 66H. Okay, so I have taken the next memory location. You can observe that this D0, that means 66H, has got the first value as 01. Okay, now what it will do, it will go to the next. Now this is the first number with what we have taken in the 66H. Okay, so this number is going to be compared with the second number. Still we have not taken any second number from the memory location. Okay, so what we are going to do now, we have to jump to the next memory location. Okay, so increment R0. Now the first memory location was your 40. Now your next memory location will become as 41. Okay, so it has incremented R0 and it will go to the next memory location. Now what is the content in the next memory location? It is 02. Okay, so it will transfer the contents of the next memory location, that is 02, to the accumulator value. Okay, so you can check the accumulator value, which will get the value as 02. Okay, so that is transfer the contents indicated by the register R0 to the accumulator. Okay, so after executing of this instruction, I'll get the accumulator value as 02. See here, the accumulator has got the value as 02. Okay, now it is going to compare the two contents now. Okay, so what are the two contents? The accumulator has got the value as 02 and the contents in the memory location 66H is nothing but 2. Okay, so 01 and 02, which one is the bigger? The accumulator value is the bigger one. Okay, so it will compare. If both are not equal, it will jump to the down label. Okay, so what is this down label? Down label is nothing but it is JCL1. Okay, so JCL1 is nothing but it will jump with carry. Okay, so what is that jump with carry? Now suppose if the carry, that means if the accumulator number is greater than the content in the memory location, uh, it will jump, it will not jump to the label, but it will directly execute the next cycle. If the carry flag is set to 0, that means jump with carry. If carry flag is set to 1, it will jump to label. If carry flag is not set, it will directly do the next execution. Okay, so what this is saying, that now it will jump to the carry flag, it will check the status of the carry flag. Okay, so after execution, it will go to this down label, it will check the status of the carry flag. Now the carry flag, it is showing 0. If the number in the accumulator is smaller, then it will generate the carry. If it is already larger, then it will not generate the carry. Okay, so we'll check this, we'll execute this program. Okay, so it has jumped. Now see here, from here it has come to the down label. Okay, so it will check the carry flag. Okay, so after execution, it will check whether the carry is generated or not. So the carry is not generated. So if the carry is not generated, it will execute the next cycle. If carry was generated, then it would have gone to the label L1. Okay, now this label. So what it will do, the accumulator value will be moved to the location 66. That means the accumulator value that is equal to 02 will move to the next location, that is it will restore the number in the 66H. Okay, I'll just execute this program. You can check your accumulator, that means your location, that is 66H, has got the value as 2 now. Okay, got it. So it will come to the next instruction. So it will again decrement and jump, not 0. Okay, so what it will do, it will compare the registers R1, okay, with 0. Okay, so what it is saying, that it is the decrement and jump, not 0. Okay, that means register R1 will be compared and whether it will be checked whether it is 0 or not. Okay, if it is not, if it is equal to 0, it will just directly end. If it is not equal, then it will go to the label. Okay, so what is the label? Label is nothing but again it has to increment your register R0 and it has to go to the next memory location. Now the earlier memory location was 41. Now the next memory location will become as 42. Okay, now you can check the status of this R0. Now after execution of this instruction, your register R0 value will get as 42. Okay, so I'll just execute this instruction. So the first of all the counter has been decremented, that is register R1, because we are saying decrement if not equal to 0, the decrement and jump if not equal to 0. So if R1 is not equal to 0, so it will decrement first of all and then it will jump to the label. So it has decremented the register R1. So instead of 09 it has become 08 now. Then it will increment the register R0. Okay, because it has jumped to the label now. Okay, label is up where we have indicated at the line number 5. Okay, so it will increment your R0 now. So R0 will become as 42. Okay, so you can check here. The number has got as 42. Again, the contents of the memory location from the register indicated by the register R0 will be again transferred to the accumulator. Okay, so what was the memory location? 42 now. 42 means what will happen? The value will become as 03. Okay, so you can check the accumulator value will get as 03. So you can check the status of the accumulator, it will become as 03. Okay, so it has got the new number from the next memory location. Okay, again it will compare with the accumulator value and the 66H. Okay, so earlier the value was 02 in the 66H. Okay, it will compare with the accumulator value 03 now. Okay, so again the accumulator value is greater than the memory location value 66H, hence the carry flag will not be generated. Again it will repeat, it will decrement your R1 and then it will go to the label up. That means again it will increment your register R0. In this way it will just go on doing the process till your counter R1 will not become, it will be equal to 0. Okay, so this is 10 times the loop is going to be repeated for the 10 times, because we have seen that we have given the 10 numbers now in the memory location 48. Okay, so the last result will be stored in the memory location 66H. Okay, so if you just generally observe these 10 numbers, can you tell me which one is the largest number? The largest number is A. Okay, so I'll execute this program line by line. Okay, and you can check the last when this register R1 will become equal to 0, your last value, that means the result will be stored in the 66H and that value will be equal to 0A, because this is the largest number what we have given from the arrays of 10. Okay, so arrays of 10 numbers. Okay, let's just go on executing. Okay, so you can just check the status of the registers, how it is going to change, and then you can check. So it has become 3, 1. So this is the last loop now. The counter has become 0. Okay, so now you can check your answer, which will be stored in 66H. Okay. Your answer has got been stored in the memory location 66H. Okay, so from the 10 numbers from 0 to 0A, which is the largest number? 0A, and that has been stored in the memory location 66H.